Ever wanted to detect objects in games? Maybe you wanted that slight little edge to be able to make it that slight bit better. Well, in this video, we're going to challenge ourselves to be able to perform object detection for games on your desktop, and best of yet, we're going to try to do it all within 30 minutes. Ready to do it? Let's get to it. Right, so in this video, we're going to be very much focused on object detection for a game. Now, the game that we're going to be using is Timberman, but if you wanted to use a different game to try to do this challenge yourself, you definitely could do that. Now, in terms of how we're going to be doing it, first up, what we're going to be doing is we're going to be leveraging the YOLO v5 deep learning object detection model. So this is a high-performing model that's particularly good for object detection. Then what we're going to need to do is actually capture games or frames from our specific game. So this is going to give us some training data to be able to learn all of the different types of objects that we want to detect. And then last but not least comes the actual implementation. So we're actually going to need to try to use OpenCV or something along those lines to be able to detect the different objects within that game in real time. Let's do it. Now, in order to give a little bit of context as we're actually going through and building up our deep learning system, we're going to be speaking to our client as we're going through, and we're going to break it up into individual missions. So ideally, we can have a full-blown object detection game system right at the end. Let's go and have a chat to our client. Hey Nick, you think you can apply object detection in games? Sure can, just need to capture the games from the frame. Once that's done, it's pretty straightforward. Sweet, you wanna give it a crack? All right, let's do it. Might do it for Timberman. I've been trying to beat my high score on that lately. Hold up. What are you doing first? First up, what we're going to do is load up the YOLO model and get it working for generic images. All right, nice, good luck. Welcome on back to the breakdown board. So in order to do this, what we're going to need to do is capture our game frame. Now, this could really be any game. In our particular case, it's going to be Timberman. I'm going to try to draw an axe here. That's sort of our axe. And what we're actually going to do is capture this from our computer. So if you had other games that you wanted to do this with, you definitely could. It'd all just be a matter of ensuring that you're capturing the segment of the game that you actually want to detect objects through. So that is our game frame. Let's color in our axe a little bit. So that's going to be our axe. So we're going to do that using a specific library, probably PyAutoGUI, and this is actually going to give us really fine-grained control as to what region of our screen we're going to capture. What we're then going to do is we're going to then pass that through to OpenCV. So this means that we'll actually be able to capture those frames in terms of Python. So we'll then be able to do stuff with the image that we're actually rendering. This is my amazing image of what Timberman actually looks like. So once we've actually got those frames, we're then going to take that particular image and we are going to pass it into a tool called Label Image. And the nice thing about Label Image is that it actually allows you to label specific images. So let's say, for example, there's a tree, we'd be able to draw a box around that and say that that's a tree. Then we might have a specific obstacle and we'd be able to actually label that. So this is going to be how we generate our training data to be able to build our deep learning system. Then once we've actually got that all sorted, we're then going to take all those labels and those images and we're going to pass it into our YOLO v5 model. So the YOLO v5 model uses a specific type of deep learning or a specific task within deep learning called object detection. And the cool thing about this is that we can take our labels and our images and we can train this deep learning model, also referred to as fine-tuning or transfer learning, because we're already building up on top of an already successful model to be able to detect different objects. Now, I think for Timberman, what we're going to try to do is detect the left side of the tree, because the goal of the game is to actually chop down the tree, but you need to avoid specific obstacles. Namely the left obstacle and the right obstacle, which are going to be different branches on the tree. So we want to train our model to be able to detect when those left objects and when those right objects are appearing above us. So we'll actually label each one of those objects. Now, if you wanted to integrate this into a bot, then probably what you're going to want later on is something like a game over signal. So we'll actually train on the game over signal as well. Game over. And we'll also train to pick up Timberman. So eventually what we're going to have is we're going to have our game frame. And let's say that this is our tree. We will actually be able to detect the obstacle on the left. So let's say our detections are going to be in red. We'll actually be able to detect where this is an obstacle and where this is an obstacle. And let's say Timberman is down here. I'm going to draw him in purple. We'll actually then detect where Timberman is as well. So this might say right, this might say left, and this might say Timb. So we'll actually be able to use all of these detections later on, maybe to do something else, or in this case, the goal is to get to this stage really, really quickly. But let's give it a crack. Let's jump back over into it and get started.
Alrighty, so the first thing that we told our client that we were going to go on ahead and do is get the YOLO model up and working. Before we do that, let's have a quick look at what YOLO actually is. So the YOLO V5 model is an absolutely amazing library which has been developed by the team at Ultralytics. And the cool thing about this is that it allows you to perform object detection relatively easily. That being said, you do need to take note of a couple of key things. So if you actually go to the documentation and you go to train on custom data, it actually gives you the steps to actually go on ahead and build your model. Now, we're going to need to set up this dataset.yaml file a little bit later on, but it's actually got the steps, and all of the code that I write inside of this challenge is going to be available via my GitHub in the description below, so you can pick that up if you want to go with it. Okay, but first things first, what we need to do is install and import some dependencies. So the YOLO V5 model is based on top of Pytorch. So if you actually wanted to go and install Pytorch, I've got the instructions in my notebook, but if you wanted to go from scratch, you can go to pytorch.org and then hit install, and it's going to give you the instructions here and basically give you the command. Normally I go stable, Windows, pip, Python, and then CUDA 11.3, but this is all going to vary depending on whether or not you got a GPU on your machine, which I highly recommend if you're going to be doing object detection. Okay. So first things first, we can run that command, and that's going to go on ahead and install Pytorch for us. And this is Pytorch, which is accelerated by a GPU. You can see that there. So I'm using CUDA. Then the next thing that we need to do is actually clone down the YOLO V5 library. This is because the YOLO V5 library's got all of the training commands and all of the pre-built models that we can actually leverage. So it does make our lives significantly easier when it comes to actually doing this and getting it up and running and at least detecting our objects in our game. So we're going to go on ahead and clone this down. So let me just quickly show you the directory that we're working in at the moment. It doesn't have anything in it. So I've just got my virtual environment. Let me zoom in on that so you can see. So that's just my virtual environment there. And this is the notebook that I'm currently working in. So there's nothing else in there, but we're going to need to do a little bit of magic to get that up and running. So if we go on ahead and run git clone, this is going to start cloning down this repository, YOLO V5. So we should have all of this stuff available here in a sec. Now, it might take a little while to git clone, but we'll give that a sec. All right, you can see that that is now appearing over there. Cool, so that looks like it's done. So as soon as you get this command inside of Jupyter Lab, that means that you are effectively up and good to go. Then the next thing that we need to do is actually go on ahead and install the dependencies for YOLO V5 into our environment. Now, the basic run through for that is to go into this environment. So cd YOLO V5, which is going to go into here, and then run pip install -r requirements.txt -- upgrade. So that is effectively going to come in here and install all of these dependencies that you see inside of the requirements.txt file. If you wanted to do this manually, you definitely could as well. In this case, it's going to make our lives a little bit easier. Now, keep in mind, because we've already gone ahead and installed the appropriate Pytorch version for our machine, it's going to skip the Pytorch implementations, and we've installed the specific version so we can use a GPU. So I'm going to go on ahead and run that command, and that's going to go through, run, and install whatever it is it needs to install. And then we can start to import some dependencies and load up a baseline model. So we'll give that a second. Cool. So that looks like that is now done. Then what we're going to do is import these dependencies. So we are going to import 3 things. That looks like we've got a bit of an error. Okay, we can fix that one. So the 4 lines that we've written there are import torch. So this is going to import Pytorch. Let me make sure I'm zoomed in. I am. From matplotlib, import pyplot as PLT. So this line is going to allow us to visualize the detections that we've got. Next line is import numpy as NP. So this just allows us to do a little bit of data processing. And when it comes to actually capturing our game frames, is going to be highly, highly important. Then I've imported OpenCV as well. So import CV2. So we're going to use CV2 a little bit later on once we get to the screen capture. That's going to make our lives a little bit easier so we can actually render each one of the different frames. Now, let's take a look at this error there. So this is saying progress not found. Oh, so this is relatively easy. I've actually got the fix for this down here. So then we can install ipy So that should resolve that particular error there. And the line there is !pip install ipy. So far, we've now gone and installed all of our baseline dependencies. We are now up to loading up the baseline model. So the model that we're going to be loading is the YOLO v5 small model, and we're going to go from local. So what I'm doing here is I'm saying that I want to load up YOLO v5, I want to load up the small version, and we are going to be grabbing it from our local repository because we've already cloned it down. So all the models are actually stored within this GitHub repository, so we don't need to go and download them from scratch. So ideally, if we run this, all things holding successfully, that's going to go on ahead and download, and we've got a bit of an error there. Let's quickly scroll down. So if you do get this error, what you can do is try to force reload. So let's grab this command here. Add a comma, force reload. And that is going to download the YOLO v5 model. So the full line there is model equals torch.hub.load. The first parameter or the first positional argument is YOLO v5. The second one is YOLO v5s. We are then going to point to the local source, but in this case, because we've going and downloading it for the first time, we need to force reload it. So I've written force _ reload, and I've set that equals to true. So if you get down to this bit here where it sort of says adding auto shape, that means that you've successfully gone and downloaded the model so that you can actually start using it. So if we go and minimize this, hit model, that is our YOLO v5 model at the moment. Now, keep in mind the model that we've just downloaded is going to be fine-trained later on to be able to do our game object detection. So this is just downloading almost like, think of it as a template, which has already been trained on some stuff, but is not going to work for our game just as of yet. So that is step 2 now done. So we've now gone and successfully installed and imported our dependencies, and we've also loaded our model. Now, the first thing that we probably also want to do is just ensure that this baseline model works. So this little flow that you can see here is actually originally from the YOLO v5 repository on GitHub. So we're going to pass through a link. So image equals https://ultralytics.com/images/zidane.jpg. And then we're going to take that link and pass it to the model that we just downloaded. So we're going to say results equals model, and then to that model, we're going to pass the image. So if we actually type model and then pass through the image, we need to run that. This is actually going to go on ahead and make detections. Now, if we actually type .print, this is going to print out the results. So from there, you can see that we've got one image that we're making detections on. It's 720 pixels by 1280. It has detected 2 people in there, so 2 persons, and it's also detected 2 ties. So you can also see the speed. So it took 469 milliseconds to pre-process and 102 milliseconds for actual scoring. Now, if we go and actually render that, so let's go and run these 2 lines here. It's going to do the same sort of thing. This is where matplotlib comes in. So remember, we went and imported in matplotlib from up here. So matplotlib inline, so this little magic command, so %mark matplotlib inline allows you to render visualizations inline. And then if we actually type in plot.imshow np.squeeze and then results.render, this is actually going to show us the results from this particular detection up here. So if we run that, you can see that we're getting detections. This is from the baseline model. So we've got a detection of a person. So that's Zinedine Zidane raging. And you can also see that it's detected his tie successfully. So it'll give you the class name. So in this case, person and tie. And it'll also give you the confidence metric. And this is how confident the AI model in the background is that that is an accurate detection. So person, 67%, tie, 68%, person, 88%, tie, 26%. So it's just sort of got his tie there. So not too bad. Cool. Alrighty, so that is the results that we need to take a look at, and you've also got all of that's how you can access the baseline NumPy array of the results as well. So in this particular case, we're rendering it. If you actually wanted to go and just grab the array, you can do that as well. What else do we have available via results? If we type in dot, we have like 2 lists. What are we getting out of that? So those are our detections. Pred. So these look like the different bounding boxes that we've got available. So I'm guessing it's X, Y. What else do we have through here? X, Y, W, H. So this must be the class. Where's the class? Interesting. So names. Those are all different class names. So these are the class names in the baseline model, right? So this is, or these are all the different objects that you can actually detect using the raw model. So quite a fair few classes that you've got there. What else do we have? Got N. That's number, I'm guessing. Names, we've already taken a look at that. Pred, pandas. What does pandas give us? Not too much, to be honest. What's S? That's the size. T. So this looks like confidence metrics. Display, what's that? Probably just a render. Trying to work out where the actual classes are. So print. Interesting. So results. If we type in .print, what does that actually do? I don't actually know how to get the classes out of here. So YOLO v5. Let's go to documentation. YOLO v5. I'm just curious. This probably isn't really needed all that much. YOLO v5 classes. Where do we actually get this from? Install inference. Show. So out of our results, we can get results.print, results.show, .pandas. What is pandas giving us? So results pandas. And pd.dataframe maybe. It's not actually working. Results.pandas. .show. What's .show give us? That is actually just showing it up here. What else? So these are sort of the commands that you got. So .save. What's .save? That's saving the results of that detection. So we can actually go through and take a look at that. If we go to runs, YouTube, and then Timberman runs detect exp. So it's actually gone and saved the image with those detections. Interesting. .crop. What's that give us? Oh, there we go. So we've actually got some results now. All right. So .crop is giving us our label. So you can see that. Let's actually take a look. So shape. What is this? This is a list. So if we go to type in len. So we've got 4 objects in there. Okay, so this is how to actually get the detection. So if we go results.crop, that's actually going to give us our results. Hit 0. So that is our first detection. So you can see it's given us the bounding box. It's given us the confidence interval or the confidence metric. It's also given us the class. So class 27 right there represents a tie. So this is all the, if you actually wanted to access the raw information for these specific detections. So it looks like results.crop is going to save out the results, but at the same time, you're going to get the results for those individual detections. This is giving us the entire image in that particular case. If we wanted to just grab the next detection, so that is a person with confidence 67. The class is class 0, so that is what the specific class for this particular model is. Because remember, when we go to results dot what was it, n? Nope, names, right? So the first class is going to be person, which is exactly what's that there. So class 0 is corresponding to person. All right, cool. So that gives us an idea as to how to actually go on ahead and get the results. So now what we actually need to do is capture the screen. Let's quickly jump back over to our client, have a quick chat, and then we'll be right back.
So that's the model loaded. Now we've got to get some data. Data? Yeah, so we need to capture frames from the game for training our deep learning model. Once we've captured them, we can begin to label each of the different types of objects that we want to detect. This could definitely be extended to different games or different objects later on. Got it.
Alrighty, we are running out of time. So we're 14 minutes down. So the next thing that we need to do is actually go on ahead and capture the screen. So what I'm going to do here is install Pytorch GUI. So this is going to allow you to actually capture frames from your screen. So the next thing, so in order to do that, I've just written !pip install Pytorch GUI, and then imported a couple of dependencies. So import Pytorch GUI, import CV2, and then import NumPy as NP. Then I've written this a little loop here, which actually allows you to take screenshots of your frames. And in this base format, this is actually going to capture a specific region of our frame. So let's quickly take a quick look. So I've written while true, so it's just going to keep looping until we break out. Screen equals Pytorch GUI.screenshot. So this is actually what allows you to capture a screenshot. So if I type in, let's import Pytorch GUI first up, Pytorch GUI.screenshot. So that's taken a screenshot of the entire screen at the moment. Now, if we wanted to, what we're actually going to get back out of this is an array. So what have we done there? Let's jump back over to here. So if I type in res, that's just an array. So let's actually convert it to an array. My bad, it's not an array. Right, so that's going to give us a NumPy array. Then if we wanted to capture specific regions, we can actually just use some slicing. So this is just Python functionality, right? Right, so then if we type in matplotlib.imshow, right, so we're grabbing specific regions. So if we wanted to grab, I don't know, the first 200 pixels by 200 pixels, that is doing that. Now we are specifically going to be wanting to grab Timberman from over this corner. But for now, let me show you how this entire flow works. So you sort of get the idea. This is going to allow us to capture a screenshot from our screen. Then what we're going to do is we're going to crop the region that we specifically want. Now, you might need to change this depending on the size of your game or the size of the frame that you actually want to capture. In this case, we're going to go from 20 pixels or 25 pixels to 625 pixels in height. We are going to go from 1122 onwards in terms of width, and we're going to grab all of our channels because we want an RGB image. We are then going to correct our colors. So corrected underscore colors equals cv2.cvt color. We're going to pass this cropped region to that, and we're just going to convert it from RGB to BGR because that's what OpenCV likes. So we've written cv2.color underscore RGB to BGR, and we've passed that through to the cv2.cvt color method. You've probably seen me do this a bunch of times before. For now, we're just going to make some baseline detection. So we're going to pass the corrected image into our model that we had from over here. Right. And then we are going to render the results using OpenCV. So cv2.imshow, we're going to name the frame YOLO, and then we are going to squeeze out those results and render them in real time. Again, I'm going through this pretty quickly, but because we're on a time constraint here, but all the code's going to be available in GitHub as well. So what are we doing here? So then we are going to be shutting down our frame. So this is just some normal CV2 methods. All right, cool. So that looks like it's working. So it's capturing our frame. So our model is actually running in that OpenCV frame. So as soon as I run that, you can see that it is capturing data. For now, you probably can't see too much because it's just grabbing whatever's over here. But if we bring, let's actually Google for some stuff, right? So let me type in cars. Right, so this frame over here is actually using YOLO right now. You can see it's making detections. Pretty cool, right? Okay, enough messing around. So that gives us at least our initial model up and working. So it's capturing frames from our game. The next thing that we actually need to do, or it's capturing frames from our screen. Let's actually open up a game. So I'm just going to open up my Steam account, start Timberman. Okay, so, and I'm going to put Timberman right up here. I don't want audio. All right, so we've got our game up and running over there. Let's minimize this. let's actually just quickly rerun this model. All right, so this is Timberman. So you can see that it's perfectly captured the Timberman game. And this is primarily because of these little components over here. So we have specifically gone and filtered it out so that it's going to capture Timberman in that top right-hand corner. Now, if you needed to have the frame somewhere else or of a different size, you'd probably go and tweak where that actually is. But for now, we know that that is looking all good. It's capturing our frame. So if we actually go and do stuff, it's saying that that is a TV. That's a laptop. Not quite correct at the moment. But remember, we're going to go fine tune. Right. So it's capturing stuff. Is it actually detecting anything as of yet? There is no way we are making this in 30 minutes. Okay, all right, so I'm going to close this down. So you sort of get the idea. It's capturing Timberman at the moment. The next thing that we need to do is actually collect some data. So we promised our client that we actually need to collect some data to be able to go and label our images. So we're going to do exactly that. And in order to do that, I'm going to import 3 libraries. So import UUID, import OS, and import time. And then we are going to define where we want to save our images. So I'm going to save it into images_path, or I'm going to save it into this specific directory. So data and then images. To do that, I've written images_path equals os.path.join. First parameter is data. Second folder is going to be called images. So we actually need to create that folder first up. So let's go into our folder for Timberman. So I'm going to create 2 folders. I'm going to create one called data. And then inside of that, I'm going to create another file, and then I'm going to call this images. And we're just going to create another file as well. Let me zoom in so you can see what I'm doing, because it is probably tiny on your screen right now. So we're going to call this labels. All right, cool. So we've got 2 folders that we just created inside of our main folder. So we've created a folder called data, and inside of that, we've got a folder called images, folder called labels. Coolio. And all of this other stuff is just, that's actually being created as a result of using and training our Timberman model, or using the baseline model, not the Timberman model. Okay, then the next parameter that we've defined is the number of images that we want to collect. So we're going to collect 100 images. We're not going to label on all of those because we just do not have the time, but you definitely could. If you wanted to produce a more accurate model, you could definitely go on ahead and do that. So in order to do that, we are going to loop 100 times. So for image_num in range number of images, we are going to collect an image. And then this code that you can see here is pretty much identical to what we had up here with a few exceptions. So we're still doing the Pytorch GUI screenshot. We're still capturing the screen array and cropping it. The only difference is this block here, right? So we are passing through our image name, or specifically we're passing through the image path, and we're defining a specific unique identifier for that specific image at that point in time. So in order to do that, we're using uuid.uuid1. So if I type in uuid.uuid1, it's just going to generate this unique identifier, which allows us to create files that aren't going to overwrite each other, right? So we are going to leave that as it is. We are then going to correct our colors, and then we're going to use cv2.imwrite to save those images into the data folder, into the images folder. So that we should have a bunch of images inside of that images folder in a second. We are then going to go on ahead and make detections. We probably don't even need to make these detections, but we'll leave it there for now. And we're going to have a little bit of a break between our screen captures. So this gives us time to allow the game to change frames. And so it gives us a little bit of variability in terms of what we're actually going to be capturing. Now, what we want to do is we actually want to play the game as we're capturing these frames. So it's going to get some variations in terms of what it's going to see in that game. So let's actually move this to the side. So my game's still playing up here. So let's actually go and capture some images. What have we done there? So number of images not defined. So we need to run that cell and then run that cell. All right, so this is capturing frames as we speak. So let's let ourselves die. So we get a bit of variability. All right. And you can see down the bottom over here, it's actually collecting images, right? I'm just trying to play a bunch of frames. And so this little clock up here, or I don't know what you call that, time check thing is actually representing the fact that our code is still running. So at the moment, it's still, all right, that is it done. So it's gone and captured all 100 images. So you can see it's gone and printed all of those out. Now, if we actually go into that data folder, into our images folder, wait, nope, we're inside of the YOLO v5 folder. If we go into our data folder, into our images folder, we've got a ton of images captured there. So you can see all of them are now available there. Let me quickly jump back, show you that. Got into data, images, we got a ton of images, right? So this gives us a ton of variability. Now let's quickly go on ahead and do a little bit of cleanup. So right now we've got this sort of dark image. We don't want that. We're going to delete those. We don't want that one. We don't want that one. We don't want that one. Let's get rid of those ones. So anything that is really, really dark and doesn't actually have any game images or any actual value of the actual frame, I'm just going to get rid of it. Likewise, anything that's a complete duplicate, I'm going to get rid of that. Because remember, I was blabbing on and we captured all of these game over frames. We can actually just delete a ton of those because we don't need too many of those. We'll leave the rest. We're not going to label all of these because we just don't have the time, but you definitely could. Okay, so those are our images captured. Now, if we take a look, it's just a capture from our game, right? Now, the next thing that we need to do is we actually need to go on ahead and label these objects. So let's quickly go back and have a quick chat to our client, and then we are going to get into labeling game objects.
Saw on Discord that you managed to capture the game frames. What's the next step? Well, now we can label the objects in Timberman using label image. Right. So what objects are you going to try to detect? Probably just the right and left tree obstacles, the game over label, and we'll maybe even label Timberman himself. Cool. Could this be used as part of a bot or something later on? Sure could. Nice.
All right, and we're back. So what we need to do now is label our game objects. We have 5 minutes left. Oh, this is not going to happen. Okay, so we first up need to go on ahead and clone down the label image package. So if I go to label image, this is what is called a graphical image annotation tool, and it allows you to draw bounding boxes. So whenever you're doing object detection, you always draw bounding boxes around the objects that you want to detect. That is exactly what we're going to be able to use label image for. So this first command here, so exclamation mark, git clone, and then https://github.com/2talin, I can never pronounce it, /label image is going to clone down that repository. And then these next two commands are actually going to go on ahead and install it. So exclamation mark pip install pyqt5 lxml-upgrade is going to install pyqt5 and lxml. And then this next command is actually going to allow us to leverage label image. So this is almost like installing it. So if I go and run that, that should get it up and running. So let's give that a second, and then we should be able to start up label image. I'm watching time tick down as we're recording this, and I'm like, oh, we are not going to make 30 minutes. Okay, let's let this run and install. So this at the moment is cloning down label image right over here. So if we go into our main folder, stop lagging. So you can see that it's gone and started cloning down label image. So it's going to clone that down, and then we should be able to start it out with just by running, what is it, label image, and then that'll start off the system. Come on. All right, I'm going to get a prompt ready because what we're going to need to do is go into our folders. So let's activate our Timberman environment. And then once that is finished cloning, which seems like it's taking an absolute ton of time at the moment, we are going to be able to start labeling our images. All right, I'm going to fast forward through this. Not my fault, my internet is slow as hell. So let's give that a sec.
5 minutes later.
All right, that is it now cloned. So you can see that we've got label image up in here. Now, the next thing that we need to do is actually start it up to start labeling our images. So what I'm going to do is type in label image. And it is not appearing. Label image. How do we start it up again? That should be it. And it doesn't seem to want to come up. All right, pip install label image. Why are we not opening? Okay, there we go. That's better. All right. So I had to go and write pip install label image there because it didn't seem like that other installation had worked. Okay, so this is what label image looks like. Then what we need to do is go into the folder where all of our images are. So if we go into data and then images and then select that folder, we've got all of our images there. The other thing that we want to do is change our save directory. So we're just going to save it into, we'll actually just save it into the same folder. Save it into the same folder? Yeah, let's just save it into the same folder. Okay, now we are here. So what we actually need to do is label our images. So we're going to label this as a left object. We're going to label these as a right object. We're going to label Timberman as Timberman. And when we get to the game over screen, we're going to label that as well. So to label, you just need to hit W on your keyboard, then draw a box. Relatively easy. So this is going to be left OBS. So left obstacle. I'm going to call Timberman Timberman. And I think that's it. Let's just double check that that's gone and saved. So if we go into our folder, YouTube, Timberman, data, images, that is a label, right? So if I open that up, come on. It's not coming. That's what an annotation looks like. So the class and then the bounding box coordinates. All right, so that is the first one done. Let's go to the next one. So we can hit D, go to the next one. And that looks like it's crashed it. Let's close that now. Oh God, this is not going well. All right, let's start label image up again. And then open our directory. So we're in the right directory. Change our save directory. You know what? Let's save it in a different directory just in case that's causing the crashing. So if I go and label that, so that is going to be, what is it? Left obstacle. It's going to be Timberman. Save. Can we go to next? All right, cool. So hitting A and D are going to allow you to go between different objects. So we've labeled our first one. Go to our next one, D. All right, let's speed through this. So we got, that's going to be left obstacle. That's going to be Timberman. Save, next. Left obstacle. Right obstacle, Timberman. We'll say that this is our right obstacle. So right OBS. Hit OK, save. We're running out of time here. All right, this is going to be left obstacle. It's going to be Timberman. Save. Next one up here. It's going to be right obstacle. Save. Next. Why is my mouse lagging? Stop. All right. Right obstacle. Left obstacle. Timberman. And if you had more time, you'd obviously do this a lot more accurately and you'd do a lot more images. So that we're going to call this game over. So I can just hit W, draw a box around it. It's called game over. Okay, save, next. And I'm probably going to start skipping over some images because we just don't have the time. Oh man, we've hit 33 minutes already. Come on, Nick. That's going to be right obstacle. That's going to be Timberman. Now I want to get some images that have slightly different backgrounds. So let's actually skip through this. All right, that's a good one. So this is going to be left obstacle. Let's go back. It's going to be Timberman. Timberman. No, go back. It's going to be right obstacle. Left obstacle. It's game over. Timberman. All right, go back. Oh, this is going to be left obstacle. I'm just going to literally just start smashing through this. This is going to be, what is this? Right obstacle. God, my brain goes blank. All right, game over. So this is slightly different game over. Background. Beautiful. Another one. So left. Timbo. What is that? Right obstacle. Save. Boom. Left. Left. Timbo. Right obstacle. Oh my God, this mouse is driving me insane. Right obstacle. It's like keeps glitching. We're just going to skip this one because we've got a bunch. Let's grab a game over for that one. And when we actually go back, we're going to delete any images that don't have annotation. So that's game over. Save. All right. I think we've done a bunch on this one before. What else? Done a bunch on that. All right. I think we've done. All right. Let's just do this one. This right obstacle. Timberman. And ideally, the more images, the better that this is going to perform. But we ain't got the time for that. So we are going to smash through this. So Timberman. All right. All right, this is a new level. All right, let's do new levels. Like variability is going to be good. So if the more examples or varying examples that we've got, the better this is likely to perform. Timberman. Let's get a game over here as well. Game over. We don't care about those. Done plenty on that level. Wish we captured some more frames on there. All right, let's capture some more here because we don't have too many of this level. That's right obstacle. It's Timberman. Left obstacle. I better go through and just double check I've gone and saved all of these because that is going to be a nightmare if they are not saved. And these are looking saved. Let's just quickly jump into our labels folder, see that we've actually saved them. Otherwise, we are screwed. All right, we've got a bunch saved. How many do we have labeled so far? 22. I don't know. That doesn't feel like enough. Let's do some more. All right, so that's the end. Let's game over. Timbo, what is that? Right obstacle. Oh my God, I'm freaking out. Left obstacle. This one's got a little bit of like shading to it, so it might give us some slightly better results. Game over. All right, look, that's going to be enough. We're running out of time. All right, so what we can then do is close that down so we don't need that open anymore. And we're going to take all of our labels. So if we go into data and then labels, so grab all of this, copy it, paste it into our images folder. And then anything that doesn't have a label, we're going to get rid of it. Or any image that doesn't have a label. So from here, that doesn't look like we've got a label there, BB. I'm just zooming in. So that doesn't have a label, so that delete those. So these are looking good. Oh, down here we've got a bunch that don't. So that is fine. So we need to delete those. Delete those. And if we needed more images later on, we could definitely go and grab it. It's just delete those. Let me zoom out. I can't see what I'm doing. So that to there. Yeah, that's looking good. Then we've got this monster chunk here that we didn't label. Monster chunk there that we didn't label. All right, so this to this should be an even number. 58. Okay. No, we still got some more over here. No bueno. How's that look? 55? Why is it odd? No. Somewhere there is an... here we go, you bastard. Delete that. Okay. 54. I think we're good. Okay, cool. We got our images. All right, where are we now? So that is our images now labeled. Let's jump back over to the client quickly, and then we need to get onto training and prediction.
All right, we're in the end game now. All that I've got left to do is train the model and make some predictions. We'll give it a crack. Can I get some words of encouragement? Nah, just go do it, mate. Rough. Slightly demanding there, mate.
Alrighty, cool. And we're back. So the next thing that we need to do is actually go on ahead and train our specific model. Now, we've got two things that we need to create here in order to kick this training off. So we need to create a dataset.yaml file. So if we go into the documentation, go to train custom data, and where is it? It should show you how to create one. Here. All right, so we need to create a dataset.yaml file, which you can see there, which has this format. So path, train, val, test, number of classes, and the names of our classes. So let's go on ahead and create one of those. So I'm just going to open up VS Code. And we're going to create exactly that. So let's create a new file. We are going to save it as, we're going to save it into our YOLO v5 folder. We're going to call it dataset.yaml. And it should be a YAML file. Save that. Okay. And then what do we need? So we need let's just copy this. So we need to specify the path to our data. So our path is going to be YouTube Timberman. So it's going to be in data and then images. Okay, so it's data. And then path to the train images relative to path. Okay, so I think we get rid of that. So then it's just images. Val, we're going to set that to images. Test, we can leave that optional. Okay, so we're specifying where let me make that bigger. You probably can't see that. So we're specifying the root path to all of our data, which is going to be dot /data. We're specifying the relative path to this path for our training images, relative path to this path for our validation images. I've just set them as the same for now because we haven't gone and split them out, but you definitely could. We then need to number or pass through the number of classes. So our class is going to be 4. Remember, left obstacle, right obstacle, Timberman, and game over. Then if we go into here, we need to pass through the name of our classes. Now, I don't know what order we had them in, but when we use label image, it gives us those. So we've got left obstacle, Timberman, right obstacle, and game over. So let's copy that, bring that over here, delete that. And we just need to convert it to strings. So quote, 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 quote. Feel like an hour is probably a more realistic time frame for this, but anyway, that's what you get, Nick. All right, cool. So that is our dataset.yaml file. So we've got path /data, train images, val images, test, number of classes, nc equals 4, and then the name of our different classes, which is going to be left obstacle, Timberman, right obstacle, game over. Order is important there. So make sure you get it in the same order as what is available inside of your classes.txt file. This is generated by label image. So you'll actually get these specific classes. All right, so how many? So we had 27. So 27 multiplied by 2 is going to be what? 54? Is that how many? Cool, we got 54. All right, just double checking that. Okay, so that is our dataset.yaml file now created. Close that, close that, close that. Oh, what is happening? Okay, close that. All right, what else do we need? So we need, let me go back into this line over here. Oh, hyperparameters. So one thing that I noticed whenever I've gone and built this before, if you've got stuff that's left and right dependent, you need to ensure that you don't have the image flipping on. This is one of the transformations that YOLO v5 does to help you improve the performance of your model. So it basically creates new images. We need to turn this off because left and right are very important and they are positional dependent. So what we need to do is grab an example hyperparameters file. So if we go into YouTube, Timberman, let me zoom in, and then go into YOLO v5, and then inside of data, inside of hypes, you can grab, which one did I grab? Oh, do I normally grab? Let me zoom out. Zoom out. So this is what an example hyperparameter file looks like. What's the high one? No, let's not use that one. Are there any others? I mean, we probably could use this one here. You know what? Let's just use that one. All right, so we're going to go into hypes, grab hype.scratch.-low. And then we're going to paste this back in to the data folder. So we've now got 2 custom YAML files. Let me zoom in. So we've got dataset and we've got hype.scratch.low. We're just going to rename this. What can we call it? What have we actually named it in our training line? Nope. What's happening? All right, zoom out. All right, we've called it hype.scratch.yaml. So let's just rename that. Hype.scratch and just get rid of the -low. Cool. All right. Then what we need to do is we need to switch that flipping off. So if we open up hype.scratch.yaml, zoom into this. Nope, not that type of zoom. If you scroll on down, you just need to switch this off. Flip dash or flip colon LR, set that to 0. So this is going to determine when our images flips left and right. So you need to switch that off. Otherwise, it is going to cause problems. You're going to get sucky detections. All right, cool. So that should be all of our training config now done. So this line should train. So we've gone and created the dataset.yaml. Is it .yml? We've got, I think ours is YAML. Let's just double check this. Ours .yml. Okay, we're good. Dataset.yaml, hype.scratch.yaml, specified which file we are going to, or which YOLO model we're going to use. I think we're good. Let's kick this off. So this is going to train. So it's going to go into the YOLO v5 file. So !cd YOLO v5. And let me zoom in on this. This is a bit small. !cd YOLO v5. So it's going to go into that YOLO v5 folder. That is then going to run the train.py command. So this is the training command to actually go and train our model. It's then going to specify the image size that we're going to use. So image or dash image equals 320. It's going to specify our batch size. So dash batch equals 16. How long we want to train for. So this is going to be the speed of this is going to be very much dependent on whether or not you're training on a GPU or not. So we've specified epochs as 2000. Then we've specified what our data path is. So dash data, we have pointed it to dataset.yaml. We've specified our hyperparameters. So dash hyp, and we've set that equal to hyp.scratch.yaml. Specified our worker weights, and this is going to preload our YOLO v5 model. So this does something called transfer learning to ensure we get the best possible model with the least amount of training time, just a whole heap more efficient. And the specified workers equal to 2. Okay, that is a mouthful. Now, in order to double check whether or not this is running, so if you go into, let me zoom in. So if you go into YOLO v5 and then go into runs, and going to train. So that is our experiment. So that is just kicked off, and that is our model now training. So this looks like it's okay. Now, if you actually open up these images, you can see the performance of the model as it is happening. So looks like it's detecting some objects. So that was the left obstacle, right obstacle. It's detected Timberman. Looks like it's detecting game over. So really quickly, you're going to get good performance on this. This is the nice thing about these specific models. It's looking okay. Looking okay as well. We can take a look at our hyperparameters. Let's just make sure it's picked up the correct ones. Flip LR is still set to 0, so that is looking good. What else? Everything is looking okay. All right, so we just got to wait for this to finish training, and we should be good. Okay, we'll give that some time.
A little longer than a few minutes later.
Alrighty, so training has completed, and that actually took minus 45 minutes. So we technically still have plenty of time left. Okay, no, it took a while. I don't know, like 5-ish minutes. It was relatively quickly, but we've clearly blasted through the 30-minute time limit now. So yeah, I'm just going to take my time now. Or maybe we'll go kind of quickish. All right, cool. So that is our model successfully trained. So we got all of our results back. And if you take a look, do we have some parameters in here? It's not all that clear what we're actually getting out of this, but there is a whole bunch of information. Normally it says the performance of the model. Oh yeah, hold on. Mean average precision at 95%. It doesn't look, oh, okay. So down here, so what is that? 0.798. Wow, this is not easy to interpret. Let's go back into YouTube. There's a whole bunch of additional information inside of the YOLO v5 folder. So if you go into their data, YOLO v5 and then runs, and we are currently on this experiment, so EXP. So out of here, you get all the results. So what is this? So training, object loss, box loss. Here we go, precision and recall. So if we go to the final bit, so final precision was 0.79, which is actually pretty good. Is that right? Let me just hold on. Let's freeze this column. Data, filter. And I just want the last one. All right, so final precision 0.79, not bad considering we had what, like 26 images. Recall 0.33, pretty crap. Mean average precision is 0.46, 0.9 for what is this? 95% confidence. Not too bad. Okay, all right, so let's see if we're actually able to get some detections, because remember, that was the goal. Okay, so what we first up now need to do is actually load up our custom model. So that is what this line over here does. So model equals torch.hub.load. YOLO v5, we are loading up a custom model from local, and then we just need to point it to where our model is. So in our case, it's inside of the YOLO v5 folder, inside of the runs folder, inside a train, and then we want experiment nothing, or it's just experiment 0, which is just exp. We're then going to load up the weights. So if you actually wanted to get these Pytorch weights, if you go into YouTube, Timberman, where is it? Inside of weights, weights, YOLO v5, runs, train, exp, and weights. These are your Pytorch weights. Cool. So if you're like a Pytorch master and you want to bring these in, you can definitely do that. Okay, so that is that. Let's actually try loading up this model. Okay, no errors there. Let's actually grab a image. So I'm going to grab so YouTube Timberman. So let's actually grab an image test. So if we go into data, images, let's just grab this one. I'm just going to grab the name of that file. Close this, and I'm going to replace it in this line here. So that's our image. Okay, so it looks like it's detected one Timberman. Woo! All right, we're doing well. All right, so now what we can do is actually visualize this. So if I open that up, it's detected one Timberman. Obviously not that great at the moment. It's missed this over here, but we could add more images of this later on if we wanted to. Let's actually test this in real time. So we could grab another image. Let's try grabbing another one. The YouTube Timberman data images. I don't know. Grab this one. Considering we only did like what, 27 images, that's pretty good. All right, so it's detected one game over. Pretty sick. Boom, it's actually detected the game over. It is not precise at all. It is detecting way off to the right. It's kind of weird because in those results, it was actually grabbing, it actually dipped. Hold on, let's quickly go into YOLO v5 data. No, wait, YOLO v5 runs, train, experiment. Let me just take a look at these results. So if I take a look at like the last 3. Yeah, so it kind of went crap. Maybe it's overtraining or just doesn't have enough data. That'd be my guess. I don't know, we haven't seen it performing in real time. Yeah, so up here was 0.99 and then we dropped down. Interesting. I personally think we need more data, but anyway, let's test this out. Okay, so we've tested it out on a single image. You can see that we're at least detecting objects, right? So we've only trained on a really small amount of information. So if we actually now go and run this particular loop, which is exactly the same as what we ran up over here, the only difference is we're now using the custom model, right? So because we've now gone and reloaded the model, this line over here, which is doing the detections, is now using the custom model. So let me write, so custom model. All right, cross your fingers, guys. So let's run this and see what this looks like. Okay, so it's great. That's detecting game over. Clearly not right. Oh no, this sucks. I think we need more images, guys. All right, so grab detected Timberman there for, oh, all right, so that was detecting Timberman. Nope. What are you doing? That is terrible. Let's go and add more images. This is crap at the moment. All right, we need to go back, add some more images. And we are going to, where's our image capture? So we're going to do this again. No, that's just capturing our screen. This is part of the process. So we are going to grab some more images and we're going to label appropriately. Let me die. Boom. Die. Boom. we are just going to delete that one. Okay. That's another thing. If you mislabel, you can right click and delete as well. So if you screw it up, it's all good. Don't need to start from scratch. All right, surely this is enough now. All right, I can't be bothered doing anymore. All right, I'm closing this. Let's go and double check. Timberman, data, labels. Still got our classes. Left, right, Timberman, game over. Okay, cool. So let's grab all of this again. Data, images. We are going to replace. All right, there are a bunch that don't have. So over here, we know that one doesn't. And then from here to like here, there was no labels. I saw a double up. I thought I saw a double up there. So there's this huge chunk here. So I'm just getting rid of it. All I'm doing is I'm getting rid of the ones that we haven't gone and labeled because there's obviously a bunch. And then here to here, here to here, and here. All right, double check. We've got even numbers. 117. Oh my God, we've got a missing one. There is one. There is one. There is one. How many is that? 114. Okay, I think we're good. So that means we've got like what, 57 images now. That should be enough to at least produce slightly better model. Okay, cool. So given the fact that everything's all still up and running, we don't really need to do too much more. We can just go and hit this again and it should retrain, but a new experiment now. So when we go and re-trigger this training, we should get experiment 2. So if I go into YouTube and then Timberman and then where are we? YOLO V5 and then runs train. So you can now see that we've got experiment 2. Assuming that hasn't blown up in my face, that looks like it's running okay. All right, let's let that train and then we'll come back. Nowhere near 30 minutes.
And later.
Oh my God, guys, I just realized I am not even using a GPU right now. So if I type in torch.cuda.is available. Also, I realized the first time that we trained, we didn't actually finish training. Because I opened up that results.csv file, it actually errored out. Hence why it's saying permission denied, blah, blah, blah. So we never actually finished training that first time. I jumped ahead of the gun and ended up running too early. So the fact that CUDA is not available at the moment is meaning it's taking a lot longer to train. Let's just double check. So I'm just going to reinstall Torch. You might not run into this problem. You might run into it. Who knows? But this is obviously, because I thought that many images probably would have been okay to begin with. But let's try reinstalling Pytorch to get the CUDA version. And then fingers crossed, I'm hoping we can train a little bit faster and ideally get a model that performs better. Because those precision and recall metrics were pretty crap to begin with. Yeah, so just a little bit more on that. Whatever you do, do not go and open up that results file while it is training because it's going to throw out errors because it's actively logging to it. So if we actually go into YOLO V5 runs, like literally as we were running that second time, I went and opened up this file, which was up to epoch 16, which caused that error to come, which meant it actually stopped running. Could not install packages. Let me just double check. So if we go and restart this kernel, restart. Cool, that's started. So let's re-import Pytorch. Okay, so now CUDA is available, so it should train a lot faster. So if I go and delete that, let's actually just run back over. If we go and kick this off now, this should train way faster. So let's run this. All right, so let's let that train. I'm not going to open up the results file. Fingers crossed we got a better model in a second. So I'll be back.
More moments later.
Alrighty, so I've let this train for quite some time now. Not the full 2000 epochs because that is an absolute ton of time. Let's actually take a look at where we got up to. So would it have been, so if we go into YOLO V5 and then go into runs, go into train, go into, that would have been the last experiment. So what were our final results? So we trained, so we trained for a long time. So we trained for 1,484 epochs. So you can see that there. That's now gone. So we almost finished the full training run. So it wasn't far off, to be honest. Let's zoom in so you can see that a bit better. So let me just freeze that first row. Data filter. I forgot all the shortcuts to Excel. Stop. All right, so let's go to the last one. So what did we get up to? 1,484. So this should perform a ton better. Okay, let's take a look. So precision 0.99, recall 1. So mean average precision 0.995, MAP 98. So this should perform a whole heap better now, guys. Cross your fingers, this actually works. Okay, so let's actually go and give it a crack. So again, what we're going to do now is we are going to reload our model. So we are now going to reload, rather than reloading the base one, the latest model that we trained was experiment 5. So if we go into YouTube and then Timberman, YOLO V5 runs train EXP5. Let's load that. Cool. So that's running on GPU. So you can see that there. Now, if we go and test out this image again, this image is not defined. Model OS. Oh, we got to re-import our dependency. So import that, import that. Okay, let's give that a crack. Boom. All right, so it's seen one game over object. Look at that. That is way more accurate there. Let me zoom in. So you can see that it's actively predicting the game over object and it's actually grabbing the full frame. All right. Cross your fingers, guys. Let's actually give this a crack. So let's run the full loop. So we've still got Timberman running over there. So we should get our little pop-up to the bottom. Oh my God. Oh, well, it's detecting Timberman as right object. Oh, it's not grabbing him. I wonder if we've just labeled the classes wrong. Do you see that? Okay, so pay attention to this. So right now it's grabbing our, hold on. So this might be because we went and relabeled our classes. So right now it's saying that Timberman is right object. Left object, it's got fine. Let me just, but right now, see this right object, it's saying that that's Timberman. So this is just a issue with the class name. So if we actually just went and fixed that up, can we reload this from, so that's loading from these particular weights. Where do we, I wonder if we can just reload. Let's go and have a look. So it's actively detecting it. I think just the order of the, we just need to switch the Timberman model and the other one around. So if we go into YOLO V5 and then runs train experiment 5. So opt, what's in here? So this is pulling from dataset.yaml, pulling from that. Hyperparameters. I wonder if we just went into this and just reordered it. So Timberman needs to be swapped with right observation. So if I change this to right OBS and this to Timberman, let's try that. I don't know if that'll work, but we'll see. How's that? Oh, we got to stop this running. Reload. How are we doing now? Game over is fine. No, all right, so it's clearly, it's detecting the objects appropriately. It's just the class labels are wrong. So this, even though it says Timberman, but you can see we've definitely gone and effectively label. Oh, there we go. All right, so it's now picking up Timberman. It's saying that that's right object as well. You can see that that is performing way better in this particular case. Could add more images. We could definitely train for longer. It's picking up that as, I think just the label names are wrong. But in this particular case, look, it's performing reasonably well considering we didn't give it a ton of information. It's picking up game over, okay. Left observation, it's getting okay. I still think the label names for Timberman and the tree are right, or wrong in that particular case. But you could definitely go and improve this. In this particular case, we've successfully gone and detected a bunch of objects in the game. It's pretty fast. I think it's just really that labeling that needs to be sorted out. But on that note, that about does wrap it up. It's detecting Timberman as right observation. You could definitely go and fix that up if you wanted to. Thanks again for tuning in, guys. Peace. Oh, look, now it's detecting Timberman, and it's detected game over as well. All right, gotcha. All right, so it was kind of killing me a little bit, an absolute massive amount, that we weren't getting really good predictions on this, because it is definitely possible. So I actually went back through and relabeled all of those images. Now, what I actually noticed was that because we labeled with one instance of label image and then went and relabeled with a completely different instance of label image, the class numbers actually got mixed up, which contributed to the less than better performance. But by re-going through and doing that, we've effectively got a way better model. And I'll actually include the final performance tuned model inside of GitHub as well. So if you want to pick that up, you definitely will be able to. But after sort of recording this video, I wanted to go and improve on it just to show you that it definitely is possible to get really good performance with this. So without further ado, I am now managed to get up to experiment 10. So you might say that it definitely took more than 30 minutes. So less than stellar performance when it comes to the challenge itself. But nonetheless, let's load up a model 10. And if we go and run our detections again, all right, so you can see that we've got our YOLO screen appearing over there. Now, if we go and run single player, take a look at that. Timberman, left observation. Booyah, it's working. Now, if we go and keep slicing through, so let's actually kick this bad boy off. You can still picking up Timberman, still picking up left observation, picking up right observation, left observation. Looks like it's working way better now, right? And so this is the impact of really just fine-tuning and ensuring that you've got your labeling right. It is so important that you get your labels right, because that's going to influence the performance of your deep learning model. Now, you could try using better performing models like the larger YOLO, but really, like, the biggest thing when it comes down to deep learning is ensuring that you've got good data. Good data is going to trump the most sophisticated model each and every time. Because if you got crap data, then best performing model is not going to do jack for you. Really got to have good data. Take a look at that. Left observation, right observation. It's picking up game over pretty well. We haven't even trained on this level. So the case in point, it's not picking up anything in this particular case. But on the levels that we have trained on, performing very well. So left observation, right observation. And because we've sort of only trained on the obstacles that are towards the bottom, that's why it's really only picking up once you get closer. Can you see that as well? And this is by design, right? Because if say you were to build a bot, you don't really care about the obstacles that are too far up, because right now they're not going to plague you, but you really want to ensure that you pick up the low observations, which is exactly what this is doing. Game over is being picked up. Timberman is being picked up. Take a look at this, guys. Dream run. All right, I died there. But take a look at that. So you can definitely tell that the model performance is significantly improved. We're definitely picking up our left. We're definitely picking up our right. You can see that there. Again, there you go. That's how to do it. And all I went back through and did is I went back through and just relabeled in one single run. So I ensured that I was appropriately picking up left, right, Timberman, and game over. And this ensured that we had good labeled images when it came to train our model. I didn't do anything else. I still trained for the same 2000 epochs. Didn't change anything else. And you can see that we definitely have significantly better performance. That's me signing out.
So, what'd you think? Pretty cool. Would love to see it used for something like game control or bot integration. Yeah, let me know what you think, guys. Should we integrate this into a bigger bot, or should we try a slightly different challenge? Thanks again for tuning in. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell. And let me know what you thought of this. Did you like the sort of time-constrained format? Is there anything else that you'd like to see? Maybe how do we take this a little bit further and add some game controls? Thanks again for tuning in, guys. Peace.